Good evening, sir.
Good evening. Okay, so yesterday we did some question. Okay, today we'll try this question. Have you done this? So a bit of speed of this class. Okay, we'll try this question today. In a hydrogen atom, the electron moves in an orbit of radius 5 into the power 11 minus 11 meter. The speed of 2.2 into the power 6 meter per second. The equivalent current will be. Wait. Can you hear me, right?
Yes, sir.
Okay, so what is given here? Speed. Speed is given 2.2 into the power 6. Now radius is given 5 into the power 11. Now for this one, what do we have? Like if you remember, speed equals to distance by time. So this is your speed. You can say equals to distance by time. So distance and time. Now it is moving in radius. So this radius, this is your distance now. In circle. This is a distance. So time equals to distance by speed. So we need here frequency, the equivalent current. We need here current. Q by T. So for all this, see current is here charge in 1 revolution. Charge in 1 revolution into total number of revolution in 1 second. So this means this is what it means, a frequency. This is called frequency. This is frequency, number of revolution in 1 second, charge in 1 revolution, and number of revolution in 1 second. That is your frequency. And here it is, that's what it's revolving around the orbit at a speed of 2.2. So with this, we can find frequency. We can substitute this frequency here. Charge, it has one charge, 1 coulomb means 1.6 value. Are you understanding what I'm saying? Turn on the camera, everyone. Come on, make a note. So what I did here generally, we want to find the revolution here. Sorry, we want to find current here, total current. So for finding current, how much current is flowing in one electron is moving in a hydrogen atom. Electron moves. So in that, how many revolutions? So that is frequency. So for finding frequency, we need time period. So for finding time, how to find time? Speed equals to distance by time. So time equals to distance by speed. So distance is here, this circle. So circle means like 2 pi r. That is what we did. So everyone understood what I did here? Okay, then make a note of it. Chanakya, Rituraj, Madhustan, turn on your camera. Samhita. Done writing? Any doubt in this question, Ajay?
No, sir.
ठीक है. Lokia?
No, sir.
What about Bhanuri? Understood?
Sir.
Devesh?
Yes, sir.
Samhita?
Yes, sir.
ठीक है. Rituraj? Okay, let's try this question. The number of electron passing through a heater in 1 minute. It's very easy. Passing through a heater in 1 minute. The current of 8 ampere passing in 1 minute, and if the current of 8 ampere will pass, then okay, no problem. Okay, no problem. Okay, what is the question here? We need to find total number of electrons. Total number of electrons we need to find here. It is mentioned here. Total number of electrons. How many number of electrons passing through a heater in 1 minute? If current is 8 ampere. So simple, like Q equals to NE, and I equals to Q by T. So mix all this here and substitute here and finish it. Chalo.
Sir, is it 3 into 10 to power 21 electrons?
21 electrons. Yeah. Check everyone. Calculate yourself. You'll see the answer. Everyone got this answer? Okay, then let's. Okay, we'll see here Ohm's law. We'll see Ohm's law today. Next. Okay. What is Ohm's law? V is proportional to I. V is proportional to here. Now, when V is proportional to I, we are keeping all the things constants like pressure and temperature. We are keeping temperature constant, pressure constant, all physical condition. Okay. We are atmospheric pressure and room temperature. We are keeping it constant. We are not changing it. So in that condition, we are saying V is proportional to I. That means whenever V is increasing, I will also increase. Potential difference is directly proportional to current, or current is directly proportional to potential difference. Now, as we can see, there is when there is a proportionality, we are removing proportionality, we will have one constant. That constant, we are naming it as electrical resistance. electrical resistance. V equals to IR. Now V equals to IR for, it will be same for V and I as they are increasing linearly. When they have linear graph, they will increase like how they are increasing like this, linear. So in this graph, what we are saying here, as this V increases, if you are observing every point, see the points. See the points. Whenever this V is increasing, it's simultaneously I is also increasing, but these both are increasing like the same way. So this graph is called as ohmic graph. This graph is called as ohmic graph. Now in this condition, this is non-ohmic graph. Except this one, not just this way. Whatever I have drawn, it's not like that. It can be any graph. Any graph except this linear, those are non-ohmic graph. What example we can say non-ohmic graph is for like semiconductors, because like they are not increasing simultaneously. Like values, they are not matching. Semiconductors, insulators, those are non-ohmic, which does not follow Ohm's law. There is a difference between ohmic and non-ohmic, that's like which follows Ohm's law. It does not follow Ohm's law. Follows Ohm's law in the sense like when there is a current flowing through it, there will be an output as this. There will be a resistance inside it, which will resist the flow of current, but it will not resist that much. Insulators has highest resistance. Okay, they are just complete resistance. They does not allow. They don't have free electrons to pass through it, like conductors. Unlike conductors. Now unit of resistance is ohm. Now let's see here resistance. So net hindrance offered by a conductor to the flow of free electrons, or simply current, that is called electrical resistance. Now it depends on size, geometry, temperature, nature, conductor, everything. It depends upon size of the conductor. Obviously, if there is a big conductor, it can flow more electrons. If there is a small conductor, obviously there depends upon size also. Size, length, area, all that. Temperature, what type of material we are using, all this. It depends upon all this. That is your electrical resistance. Make a note of this. Done?
Yes, sir.
Okay. And let's see here resistivity. Resistivity is what? Like, see, resistance is the property of some material which resists the flow of current. Okay, so resistivity is property is like it's for a given conductor. It is about uniform cross section area length A. So it is, see, in the difference between these two is like they depends resistance depends upon all this size, geometry, temperature, nature, all that. But resistivity does not depend upon size or geometry, but it depends upon temperature and nature, what type of material it is using and what it is. It does not depend upon this size and geometry. So R equals to rho L by A. That is, R is proportional to L. R is proportional to inversely. R is inversely proportional to area, and R is directly proportional to resistivity. So as per the length increase, resistance increase, area increase, resistance decrease. These things you have already studied in your 10th standard grade, 10th standard. So I'm not explaining so much here. So rho equals to m NE square tau. Tau is your relaxation time. Then we can go for next. Yeah, unit you know, right? Ohm meter and all that. Okay. This topic I think is new for you. So effect of temperature on resistance and resistivity. So there are like we are considering two metallic conductors, rho 1 and rho 2, with a resistivity rho 1, rho 2. So resistivity rho 2 is equals to rho 1 plus alpha T. So for that, like see, formulas okay, but understand this one. What it's trying to say here? See, if temperature increase, the position of ions on metal, which in that position of ion, in that it start vibrating. So with high amplitude. So due to this, their mean position or mean part decrease. So relaxation time also decrease. Even like yesterday also we discussed, like when there is a vibration in that molecules, there is a vibration in molecules. So relaxation time between two successive vibration or oscillation, it starts decreasing as there is a pass of electron or some external electric field. Okay. This is for conductors. So what about alloys? The rate at which resistance change with temperature is less. It is less than metals. And semiconductors, the resistivity of semiconductor decrease with rising temperature because they doesn't have much free electrons. So with the rise in temperature, the value of N increases, but the relaxation time decreases with the rise in temperature. So here N is dominating. Number of electrons are more, but it's not free electrons. So that is for semiconductors, alloys, and this is for conductor. Now, our electrolytes. The resistivity decrease with rise in temperature because viscosity means thickness of that fluid of electrolyte decrease with increase in temperature so that ions get more freedom to move. So it can move easily. So obviously if there is a thick, if it is viscous fluid, so it cannot move easily. So if it is less viscous, so it can move easily. Viscosity, like example, we can say oil and water. We can compare those two. For insulators, the resistivity increase nearly very, very high amount. That is why it cannot conduct. That's why it is not conducting. So it is resistivity increase very highly with decrease in temperature. So conductivity of insulator becomes zero. Conductivity becomes zero, so it cannot conduct. So make a note so that you can remember. For conductors, alloys, semiconductors, and electrolytes or insulators. Electrolyte and insulators also. Make a note of it.
Sir, you can show from the effect of temperature.
Then
Sir, what is T when 4 is equal to m by n e square? That symbol?
this is tau. That is your relaxation time, average relaxation time. Tau is your average relaxation time.